So now that you have already seen about melting and boiling point, now let's understand something about conductivity. Now students, what is conductivity? Obviously you know conductivity is nothing but simply flow of ions or flow of electrons. So that is your conductivity. So in conductivity, what happens? What happens in conductivity? Let's consider any electric current, or we say flow of electricity. There also is type of conductivity, there is flow of electron. Similarly in ions also there is conductivity by flow of ions. So if we consider our ionic compounds, obviously they contain ion. So in ionic compound, if they are in the solid state, if they are in the solid form, in that case, does they will have conductivity? Obviously not. They are in the fused state, they are not in their respective ions. So in the solid state, your ionic compounds do not show any conductivity because they are not in their ionic form. They are just generally in their fused state, just like your sodium chloride. So when we talk about solid, you know that in solid arrangement, how is the solid arranged? Your solids are arranged very properly, correct, in a single manner. If you look onto your screen, there is a diagram which shows arrangement of solid, where you have positive cation, negative anion, positive cation. See how they are arranged. They are packed very linearly and very neatly. There is no as such space, correct? There are some spaces which are known as voids, but they are linearly packed. But when you go into liquid or molten state, okay, these are not that much linearly packed. The molecules or the ions are little bit random. So in your aqueous or molten state, obviously there is formation of ion. So your ions can move but not your molecule. So your ions will move and you will get conductivity. So we can say that ionic compounds cannot conduct electricity in the solid state but can conduct electricity in the molten state. So I hope this is clear. Solid state, linear arrangement, properly packed, so these ions cannot move, hence cannot allow you to conduct electricity. But in the case of molten or aqueous state, as you can see in the diagram, correct, the ions can move, hence there is a formation of electricity. So that was about your conductivity. Now similarly you have isomerism. Now what is isomerism? Basically that is different type of arrangement of atoms, but your ionic bonds are non-directional, but covalent bonds are directional. That we will discuss afterwards obviously. But your remember one thing, ionic bonds are non-directional in nature, and non-directional in nature, that means what? It will not show any isomerism. So remember one thing, ionic compounds, keep this in mind. Such questions can be asked. Ionic compounds cannot show isomerism. Cannot show isomerism. Why? Because they have non-directional bond. Non-directional bond. Is this clear? So ionic compounds will not show any type of isomerism. Okay, let's move ahead now. Now what about chemical reactivity? So chemical reactivity means what? Basically a chemical reaction. Obviously it is very easy to understand that ionic compounds will show very fast reaction. Why so? Because they are forming into ions, and ions they can move fast. So your ionic compounds, they give very fast ionic reactions because they involve only exchange of ions. There is no bond breaking and bond formation here. Just like happens in covalent compound, there are bond breaking and bond formation, but in the case of ionic compounds there are no bond formation or bond breaking. It's just the force of attraction. Hence, in this case, the ionic reactions are very, very fast. So that is one of the property. Next is solubility. Now you know that when we talk about solubility, always remember the like dissolves like. Like dissolves like. What do you understand by like dissolve like? That means the polar molecules, the polar compounds will get dissolved in the polar solvent. and non-polar compounds get dissolved into non-polar solvents. Simple as that. So your polar compounds will not dissolve in non-polar solvent, and vice versa. So we can say that since ionic compounds are polar, so obviously likes dissolve like, so they are soluble only in polar solvents and not in non-polar solvents. So they are soluble in polar solvents with high dielectric constant. I hope this is very clear to you. So this is how your different properties work. Okay.